This episode is a beginner's guide to animation blueprints and how to integrate footstep sounds directly into your animations. So welcome to today's episode, and today we are starting some brand new stuff. You're going to learn all about animation blueprints, basically the blueprints that control how our characters move and act in the world. And once again, this is one of those episodes that if you have no prior experience, it can be pretty overwhelming, and that's okay because this is just the first of many forays that we're going to make into animation blueprints. And we're also going to start talking about sound in Unreal Engine, just very high level stuff, because what we're going to do is we're going to get footsteps from another existing Unreal Engine project that you can get just for free, and then take those footstep sounds that are really good quality, bring them into this project. So here are the key concepts today. Similar to the very first blueprint episode, so that was episode 2, you don't need to understand every single thing about all of this right now, but just at a high level, what the purpose of each one is, how they work together to drive ultimately whatever animation our character is playing at that particular moment in time. And so, let's get to it. So this is a core principle of mine. It's served me well, and it's going to keep serving us throughout this series. And that core principle is, if something is already done well, don't reinvent the wheel. I am not a sound engineer. I am not going to create the world's greatest footstep sounds. So when we can't create it, we can use what's already out there. The thing about an original game is you just have to have 2 or 3 specific things that are your hills to stand on, the things that are unique to your game, to your gameplay experience. Footsteps are not going to be that thing. The number one thing for footsteps is that they're not annoying. That's the number one thing. And so we can use existing footsteps. And Unreal Engine has a game animation sample project with excellent footstep sounds. And in order to get the game animation sample project, which is a completely free project, you do need to sign into Fab, which is fab.com. And Fab is the one-stop shop for getting all Unreal Engine assets. And then if you search for game animation sample, and it's this one right here. And within this, you can just say add to my library. And once you add it to your library, then you can view it in the launcher. And then over here in the launcher, we can create our project. And make sure to choose the correct version of your project if you have multiple versions of Unreal Engine installed. So I have some previous versions. I'm just going to choose 5.7 here. And then create. If we go back over to Unreal Engine under Epic Games in the launcher and then over to Library, it's going to take a little while to download, but you'll see the game animation sample underneath all the assets that you have in your library. And then once it finishes downloading, create project. Again, make sure that it's 5.7. And once it finishes downloading, if you go back up to the top under My Projects, you should see it right there. Let's open that up. And it's got to compile shaders as it did the very first time we opened a project. And voila, we've got our game animation sample project. And if you play, you can have some fun with the running dude, and you'll notice that the running dude, he's got footstep sounds and also jump sounds. So what we're going to do is we're going to transfer the running sound assets from this project into our project. So let me show you how to do that. If you go to the content drawer and you navigate under audio and then under Foley sounds and then under meta sounds and presets. And meta sounds are the foundational background for all sound in Unreal Engine. And so we're going to take our meta sounds here and we're going to move them into our project. And the ones we specifically need with our project are the jump, the land, the run, and the strafe. So these 4, and I'm just holding Control and then selecting each one. If I right click with all 4 selected, we can go to Asset Actions and we can do a migrate here. And we see here that there's a list of dependencies that we need to migrate. And basically it's everything in the chain that's connected to the sounds that we're going to get. And that includes all these sub sounds of jump. So we can select OK. And then we have to choose our Unreal Engine project that we want to migrate this to. And so if we go back, not our game animation sample, which is what we're in, but back into Unreal projects, and we got to choose our particular project, game in a year. And if we select that content folder within your project, and you have to specifically select the content folder. And once you're here, then select folder, and it should migrate. The most common issues here are you're not selecting the right project or you're not selecting the content folder within that project. And that's it in terms of getting the sounds we need. So we can exit out of this project, open up our game in a year project. So we're going to start this with the tour of our animation blueprint. And the animation blueprint is the blueprint that's connected to our character blueprint that handles all animation logic. Basically, it handles how one animation goes into another, like a run into a jump. And it can get very complicated because you got upper body, you got lower body, you have animations that need to blend together. But we're starting with the basics. So let's go to our content drawer. And actually, what I want to do is open up our character blueprint because I want to show you the connection to the animation blueprint. So let's go into Variant Platforming, over to blueprints there and open up our BP platforming character. So we'll maximize this. If we go to our mesh, so on the right hand side in the details panel, we have our skeletal mesh, which is the actual mesh, the structure, the skeleton of our character. But above it, we have animation mode, use animation blueprint. So you can tell a given character to use a specific animation. Like if there's a specific NPC that you just want to loop with a current animation over and over and over again, you could just simply say, use that animation. But in our case, anything that's more complicated, you need a blueprint. And that's this right here, ABP Mani Platformer. So let's click that folder to go into it. And then we'll open up our ABP, which stands for Animation Blueprint Mani Platforming. And think of the animation blueprint as the switchboard that decides which animations to play, when to play them, and how to play them. And thankfully, we can get 90% of the benefit with 10% of the work using what comes out of the box. And already you'll see a lot of parallels between regular blueprints and animation blueprints. You have your viewport in the top left. In the bottom left, you have your event graph, you have functions, you have variables. And on the right, you have your details panel. And up here in the top left, we got our Quinn mesh. So there's a really quick tip in terms of how to change the preview to see our Mani mesh. If you come up to the little picture icon here and go to preview scene settings, on the right hand side you've got the preview mesh. We could switch this out to SKM Mani simple, compile and save that. And that's just the preview window, but that's going to give us a sense of how Mani is going to look for any given animation state. So here's our event graph, and it's mildly complicated, but let's go through it. So when the blueprint initializes animation, what this is doing is it's getting a reference to whatever character owns that particular blueprint. So the owner of this blueprint is going to be our BP platforming character, but it gets that actor and then it casts to that blueprint, and casting is the simplest form of blueprint to blueprint communication, which we've covered a little bit. We'll do more with casting in the future. Based on the casting, it sets a reference, and this is a hard reference. Basically, it means we only need to cast once, we get a reference, and then from our animation blueprint, we can talk back to our character via this reference. And it gets a reference to our character movement component, because you can imagine the animation blueprint really needs to understand, is the character moving, is the character jumping? And all of that is actually controlled under the character movement component for our character. So that's why it's so essential to get a reference here. And then those references are sorted under variables right here. So then we go down here and we have this event blueprint update animation. And think of this as basically the animation blueprint equivalent of event tick. So at first make sure, okay, don't do something every single tick, every single cycle of the game, unless our character is actually valid. It needs to make sure that the character that this animation blueprint is attached to is legit. There's no point in running a blueprint over and over if it's not going to be physically connected to a character. And this, like event tick, is happening every single frame. So if the game is running at 120 frames per second, everything that's going down this execution string is happening 120 times a second. And then if we come over to our sequence node, and sequence, it's just a way of executing multiple things. So you could actually take each of these strings and put them in one giant long string, but often sequence is a simpler way to organize it. Typically, I would collapse this stuff into functions, and then I'd have like 5 different functions connected to 0, 1, 2, 3, 4. But this is why I like collapsing the functions, because otherwise you can imagine this getting overwhelming, even though it's well organized here. So the first thing it's doing on 0 is it gets our movement component. So that's the reference that's set up here. Then it gets our velocity, and the velocity is a vector. A vector is 3 different things, X, Y, and Z, similar to when we were talking about world space in our very first episode. So a velocity is like how fast are you moving in X direction, Y direction, and Z direction. And any of those could be negative. And based on that velocity, then it gets how long that velocity is, like how fast are you actually moving, and then it sets a ground speed. And these are variables that are actually here on the animation blueprint, and those variables are going to determine how the character animates. And then we keep moving down, and it says calculate direction using the delta between velocity and the actor rotation. When the character is not strafing, clamp the value between plus or minus 45 degrees so that backwards animations do not play when turning around, but running into walls look better. We're just going to trust them on this. But the 45 degrees is basically, how are you running? Are you running just in the cone that's facing forward? All right, so let's keep going down here. So the second one, set should move to true only if ground speed is above a small threshold. So if the character is moving really, really slowly, we don't want our animation doing weird stuff. So the ground speed has to be greater than 3 for any animation to play. And that's what this should move Boolean variable controls. If we come down to set is falling, so this gets it directly from our movement component, and it sets a variable here on on our animation blueprint. And the reason it's doing these things is it's always less performance intensive to reference data on the same blueprint than to have to reference something like the movement component every single time. So basically it sets the latest data here and then it can work directly with it. Comes down and it checks for double jumps because it wants to play a double jump animation. But what this is doing is making sure, okay, it's not in the process of already double jumping. And then this one is saying, have they already double jumped? Have they landed yet? And it's setting those two variables here. If you're finding it annoying to hover over stuff and you're getting this pop-up, you can just change this to no debug object selected. You'll stop getting that. All right, down to check for wall jumps. Same sort of thing. It's checking, has the character already wall jumped? If not going to let them wall jump again. All right, so that's everything that's happening on our event graph, and it's doing this every single tick. But now you're probably wondering, Neil, where's the actual animations? Like, how does the animation blueprint know when he should be running, standing still, or jumping? So that is through something called the anim graph. So first, every single tick, the event graph sets variables, and then the anim graph is going to use those variables to determine what animations to play, when they should play. So if we open that up, so whatever animation pose the character should be in at this particular moment in time, that's our output pose here. So it's best with this to start with our output pose and work backwards to figure out what's going on. So the last thing it does before it gets to our output pose is it has this control rig. We are going to briefly touch on control rig this episode, but control rig is a very sophisticated tool set for driving full body animation. So a professional animator could do an entire course just on control rig. What this one is doing is not all that complicated. You could double click on it to go into it. Still pretty complicated, but it's doing something called IK, inverse kinematics. So imagine our character's foot stepping on, so I've got a ledge right here, stepping up on that ledge. Now with a normal animation, the foot is always going to step in the same position. Inverse kinematics figures out where the thing that the thing is touching is and then works backwards. That's the inverse aspect of inverse kinematics. So it says, okay, there's a rock there. We're going to animate only as far as we hit the rock, and that's it. And it drives what each other bone in the bone structure, and those are the bones that make up our character's skeleton, which we'll also talk about in the future. But those bones are going to be driven based on the location of whatever is being hit. And here's a really quick example of IK in action. If I step up on this, you see on my foot, it still goes partially through, but the foot is adjusting based on the location of that ledge. So a typical animation drives bones forward in whatever position they should be in. Inverse kinematics receives whatever those bones hit and then moves those bones backward inversely in relation to whatever they hit. Next, we have this slot, default slot. Now, in a variety of animations, you could play those animations to just be, for example, upper body, or maybe just the right arm. So the lower body could be doing one set of animations, upper body could do another set, and that's controlled via something called slots. The default slot is typically full body, but later on in the series, we're actually going to create an upper body slot that just drives animation, so we could be running and like throwing something at the same time. The other function that this default slot allows us to drive is that in addition to the animation graph, occasionally in blueprints, like on the BP platforming character, we will say directly here, play this particular animation. And the way we do that is by calling this default slot, or whatever slot like an upper body slot that we set. So that's how we do a hook into directly calling an animation here. And finally, we get to our state machine, main states. And the state machine is a way of blending all animations together. Think of a state machine as a network of all of our animations and how they can connect. So the jump animation has to go into a jump landing animation. The jump landing animation has to be able to go into, for example, a running animation. So if we click into main states, so when we land, it goes to the landing animation and then it goes to locomotion. And this is a little weird because it's a reference to a reference to a reference. It says use cached pose locomotion. If we expand under anim graph here, you'll see a separate anim graph for locomotion. We can go into that. But basically, if the character should move, it goes from idle to walk, run, and then if they should no longer move, if not should move, then it goes from walk, run, back to idle. And each of these animation graph nodes, if we go into them, they contain other logic for determining what animation to play. This is called a blend space. It's more complicated. Let's go back to idle because idle, very simple. Idle just plays an animation, and this is a sequence player for animation, idle. And if you go to your content drawer for a moment and then go to overall content and search for that exact word, _idle, and right click and say show in folder view. And you'll see all of your animations here, like attack, go back, jog, jump, etc. These are where your actual animations out of the box live. If we go into that idle, this is called the animation sequence. And this is the core animation. All it does is it loops. And so our character is not perfectly still like a robot. They're just moving slightly, and it just loops. Basically, the last animation frame merges automatically into the first animation frame. And on the left here, we see all the bones of our particular character. And we can see that particular bone in relation to our character's skeleton. This is the complete skeleton of our character. So we can close this. We can go back to locomotion up here and then back to the anim graph. So we see our locomotion state machine, and that's what we were just looking at. And the locomotion state machine saves that into this pose here. And then in our main states, it shows how all of these things are connected. And when the character is in air, it goes through this fall loop, which is just a looping fall animation. You can see that is just like floating in air. And if we go back to main states, locomotion here, that's what connects up in our anim graph. I know this is a web of confusing references. I completely understand. Just know that it's totally fine if you don't fully understand this right now and you just have a general sense of how this all comes together. And where we're going to start with our actual footstep sounds, building that out this episode, is in the locomotion state machine, specifically our walk run node here. And the walk run node, it uses something called a blend space. And a blend space is a way of blending together multiple animations that change according to another value. Like speed, for instance, we need to move from walking into running, and we need to do that naturally over the course of our speed increasing. Another example could be moving from like running forward to a strafe. It can't just suddenly start playing a strafing animation. It has to blend slowly and carefully. So it takes these two variables, in this case, the direction our character is moving and the ground forward percentage, like that's our speed, and then it outputs an animation here. If we go into that, and we can go over to our asset details on the left, so this blend space is using a total of 27 animations here. And you see each of these nodes represents a different position in which the animation does a different thing. If you hold control, you can actually move this little green, I don't know, cursor or indicator, and you could see how the character moves over that space in relation to how fast the character is going. That's the speed over here on the left. And then the direction is the x-axis. So if we move it over to the left, the character is moving in one direction. And if we're moving over to the right, the character is moving in the other direction. So we can see the character backpedaling a lot, moving forward quite a lot. And feel free to experiment with this when you're doing player in an editor, because you can run around with AWSD and see how these animations naturally sort of blend together. And this is really the primary thing about an animator's work. Like, how do complex animations blend together to look good, look seamless? But now the question is, how do we add footstep sounds to these particular animations? And we're going to start with jogging, because everything we're doing in this game, it's all jogging, no walking. So if we expand jog forward here, and we could see the animation that's being used here, if we go to that folder, then we could see the animation, double click to go into it. And in the animation, we actually see something called notifies. So we have this R, this L, this R, and each one of those, if I zoom out, let me actually pause the animation so you could see this. So if you watch the footsteps carefully, so right about here, the mannequin has its right foot down and then its left foot right here, right foot right here. And these notifies, what they're doing is indicating, okay, at this particular moment in the animation, generate an event, notify our animation blueprint that something is happening at that particular moment in time. And these existing right and left notifies, they're really just placeholders. What we need to do is we need to add our own. So if we come a little bit before, and I'm going to right click right where I want to add it here and say add notify. And I'm going to choose right foot plant. If you don't see a notify titled R foot plant, just do a new notify up here and make sure it's verbatim. But I'm going to choose R foot plant. And this is going to indicate back to our animation blueprint, this in the animation is when our right foot is planted and should thus play a sound. And then we can come a little bit before the L. And the reason I'm doing it a little bit before is because there's a very tiny delay between when the animation actually plants and the sound plays. So here we're going to do L foot plant and then a little bit over to the right, and do this for each one, for the L's and the R's. Just make sure you don't reverse them. It's not that big of a deal if you reverse them, but try to get them right. So there we go. We'll save this animation. And then if we go back over to ABP Mani platforming and then back over over to the event graph. I'm going to zoom out because what I'm going to do is come underneath, and underneath everything, if we right click and we search for our foot plant, and we see our event anim notify our foot plant. And I'm going to do the same thing for the L underscore foot plant. And now we have the two events. Each of these are going to be triggered respectively when this particular moment in the animation plays or this particular moment in the animation. And the first thing we should do to test this is if we drag out a pin and we do a print string. And this we learned about a few episodes back, but it's just a simple way to make sure something's working. And I'm going to name this print string right foot. And I'm going to copy and paste it down below. And right here, I'm going to make it left foot. So what should happen is when we begin play, we should see in the top left corner, every time we take a footstep, right foot, left foot, right foot, left foot. Let's take a look. Left foot, right foot, right. Good. So we have our anim notifies playing on animation. What's also neat here, you'll notice that because we are only using the forward animation right now, it's always playing even if we're strafing, because if we're strafing, we're actually just turning and moving forward. Now, in the first person point of view, it doesn't play when I do that because now it's playing the left animation, the right animation. So keep that in mind. So I'm not going to spend the time going through every animation to add these anim notifies to, but it would work the same way for those strafing animations if you're in the first person point of view. All right, so let's exit out of this. And so now back in our blueprint, this is where we got to figure out how are we going to play the sound. And there's two basic ways of playing sounds in Unreal Engine. There are sounds that are localized to a particular place, like a particular location in the world, and then there's generalized sounds. So an example of a generalized sound might be like the music playing or a UI click. Typically for any sound that's localized in a location in the world, like a footstep, we want to do it sound at location. And the reason for that is then you can have something called attenuation, where the sound changes based on how far away are you from that sound. Are there things obstructing that sound? Is there echo reverberation in like a cave? Stuff like that. So we can get rid of our two print strings here, and I'm going to drag out and I'm going to say play sound at location. And the sound we are going to play, if we go back to our content drawer, back to content, if we go into the audio folder that we brought in from our game animation sample project, and then go into Foley, Meta Sounds, and then Presets, we have our Foley sound run right here. We can drag that up into our sound here. And there we go, MSS Foley sound run. Now the question is, what location do we want to play that sound to? Now we could get the location of each of the feet down here at any given moment in time, and this would be the most accurate way of doing it. But quite frankly, in testing this out, because we're always locked into our player character, the sound sounded better when I simply played at our character's location, wherever our character was. It just kept it consistent. So we need to get a reference to our character wherever our character is. Luckily, we've already set that reference as we went over at the beginning of the episode. So I can drag in a reference to our character. And from here, I can say get actor location and then connect this up here. And the other thing I can do, I can just copy and paste this down here and connect this up like this, drag down a pin just like this, and then compile and save our blueprint. And we are ready to test this thing. So if we play, and there are our footstep sounds. There's a couple other things I want to go over just to close out the episode. I do want to show you how you can get a particular bone and then play the sound at the location of that bone. So to access our character's skeleton to see the entire bone structure, we can go to it here in the top right corner. And there we have our skeleton here on the right hand side. And if we want to see a particular bone, so there's what's called a bone hierarchy, where each parent joint, and let me actually zoom out to show you this. So we have our pelvis. The pelvis, generally speaking, is the primary joint. It's in the center of our character. It joins the upper body with the lower body. So the upper body has multiple spine bones going up to the upper arms. So you have clavicle and then upper arm L, and then you have clavicle R and upper arm R. But in regard to the lower body, if I collapse spine, then we get our thigh L. And if I collapse that, then we get our thigh R. If we go all the way down, then we'll see foot R and specifically a foot R socket. And sockets we'll get into a little bit later in this series, but basically they're a way of attaching things to a particular bone. You can attach directly to a socket. So an example might be you want to wrap your hand around a sword, and then you want to attach our sword mesh to a socket within the player character's hand. But for the purposes of what we want to do here, playing sounds on particular bones, particular joints, we just need to get the name of that joint. So foot underscore R, and the other one's going to be foot underscore L. And if we go back to our animation blueprint, instead of just getting our actor location from the character, we have to get the mesh specifically. So down here, get mesh. And I'm going to drag out a little bit further delete out this get actor location because we are going to get socket location. And the socket is going to be, even though it says socket, it could either be a bone or a socket. It works the same way. So it's going to be foot R. And so for the right foot plant, I'm going to do foot underscore R. I think the capitalization here does matter. So just make sure it's all lowercase. And then if I zoom out a little bit and drag these down, I'm going to get another reference to mesh. Actually, we can just copy and paste get socket location. This one's going to be foot L, and then connect this up here, and make sure to connect mesh also to this, and compile and save and test it out. You know, see if you like the sounds better if it's playing this way as opposed to, because then you're zoomed in, zoomed out. It's a more accurate location, though it's not going to make that much difference because you're locked into the character. I think for other characters that are moving around the level, this is better. One issue I do notice, if you start running, it takes about 1 or 2 footsteps in order for a sound to start playing, if you notice this. So that very first footstep, there is no footstep sound. So what's going on there? So if we go back over to unarmed jog forward, what you'll notice is that as this animation is starting, we actually have a foot that's already down, like right there. And I experimented adding a notify here, but the problem is that notify is actually after the foot is actually down. So it doesn't match up appropriately to when the foot is actually planted. So let me show you another way in these situations when it's kind of at the edge of a particular animation, a better way of adding the anim notify. So if we go back to our animation blueprint, we have to go over to our anim graph and then into the locomotion state machine here. So you can actually trigger an anim notify when you move from one node to another. So when you begin walking or running, for instance, and that's this arrow here. So these are transition rules. Basically, if something is true, then it should transition from one state to another. If you go into that, so all that is the Boolean variable that we set all the way in our event graph that says should move here. So back to idle to walk run rule, back to locomotion. So when this transition occurs, we can trigger a footstep notify. So if I navigate over to the details panel, if you scroll down here a little bit, make sure you have the arrows selected. But at the bottom of the details panel for a given transition, you have notifications, transition start, transition end, transition interrupt. So you can actually have an anim notify if something gets interrupted. And I found that the footstep sound works best if we do this on transition end. So I'm just going to type here L underscore foot plant, or you could do R and then compile and save. But I think if I remember correctly, we can go back. Yeah, so the left foot is what's planted first. So that's why I'm doing L here. It is free text, so make sure you spell that right. Make sure the capitalization is right with 2 underscores. Compile and save that, and let's test it again. We should have our initial footstep now. And there we go. So I'm not going to spend the time during this episode, but set the same notifies for every other jogging animation, and you should also have those then in first person view. But the one I do want to spend some time on is jumping animations. So if we go back to our main states, and again, main states can also be found under the anim graph here, main states. And we see in main states, in order to get to locomotion, we have this landing animation here. So if I go into land, and go into here. And if we hit play down here, then we can see, yep, that's just the landing animation, landing on the ground. So we're going to create a new anim notify for this. And this way we can actually increase the volume for this particular anim notify so it's a louder footstep sound hitting the ground while jumping. So if we right click, add notify, I'm going to create a new notify and I'm going to call it jump land. Now, the thing about the jump land animation is that by this point, by the time the animation begins playing, his foot is already landed. So we have to do the same kind of thing. I can delete out the anim notify here. You need to create it here, but once we delete it out, if I go back to the animation and then go back to main states. So when it's transitioning to land here, I found this one is better when we do it on transition start here. So if I just type jump and then capital L for land, or just make sure it's verbatim for whatever you called that anim notify. And then if I go back to our event graph, need to come down again all the way underneath. I'm gonna right click and search for jump land, event anim notify jump land. And we could take the same nodes that we have here. I'm just gonna copy our character, mesh, get socket location, paste it down here, move these down here. And I'm doing foot L because that's the first foot that's actually gonna hit the ground. And then connect this up. The other thing we can do, if I expand this, I can increase our volume. You could do some other things here like add attenuation, etc. But I just found for our own character, the sound's always going to be the same because we're locked into our character. We don't have to worry about attenuation yet, but we will do that in subsequent episodes. So volume multiplier, I'm going to double the volume. Compile and save. So let's test out jump landing. Yep, quite a bit louder. So that concludes our episode for today. And in the next one, we're setting up a very simple level goal blueprint. When you hit the level goal, next level. So I hope to see you there.